So today we will be discussing and learning how to create a smart home automation project. Okay. So now the basic idea of this project is we have a house or bedroom where we have installed an ESP32 module, which or let's say a system which will allow us to control few things in this room. Now the basic idea is we have a sensor uh, uh, which will detect the presence of human in the room, and based upon the presence we can turn on the lights and fans. Okay. Now also we have a sensor which can detect if a human is standing in front of the door, and if there is a person standing, then it will open the door automatically, and when the person passes away or passes far away from the door, then it will close the door. Okay. And apart from that, we have another sensor which will uh, check the presence of light intensity in the room. If the room is very dark, then it will automatically turn on the lights as well. Okay, like let's say it now after evening the when room goes dark, then it will turn on the lights. Okay, so that is one more thing. And also we have a temperature sensor which will show us the room temperature, what is the temperature of the room. And let's say if we have a we have a fire detection in the room. Let's say if the temperature goes very high, then based upon that we can set an alarm using this buzzer if that you can see. And not only that, we can also, all of this is connected to a platform, online platform or a cloud platform, which is BLYNK, Blynk. Okay, so what will happen with this is we can also check the status of each and every components or each and every appliances that we are connecting, the room appliances that we are connecting to this system. And also we can check the uh, notifications of fire alarm. Okay, now let's say if there is a fire detection, then then our mobile and our email will receive a notification stating that there is a fire alert. So whatever the steps are further to be done, then that can be taken. Okay, so this is the basic idea of this project. So now before discussing the working or the uh, code and all, let's understand the circuit of for this project. Okay, so the controller that we are using is ESP32. Okay, now it has a lot of digital input output pins which are so analog input output pins. Okay, now if you want, you can check the pin diagram of ESP32, which is available, easily available online. Okay, so now simply what I have done is I have made connections here of various sensors. Okay, so let's understand each of them one by one. Okay, so now let me just zoom in, take you to the connection for each and every sensor, and also explain the circuit. Okay, so now if you can see, for this is the DHT22, which is a temperature and humidity sensor. Now this sensor we have connected, the it has 4 pins. Okay, now not all the 4 pins are connected because one is a no connection, which is NC pin. But apart from that, there are other 3 pins which we have connected to our node MCU. Okay, so what the connections are, first is here, if you can see on this terminal, it's mentioned VCC, right? So VCC simply means power supply. So now here directly, either what I could have done is I could have provided the power supply from this board, ESP32 board. But since there is a lot of wires, and uh, I tried to make the circuit less confusing or the wiring less confusing. So what I simply did is, in this uh, platform that I'm using, Walkbee, it has a feature of this adding this VCC differently, separately. So what I did is simply I just added a new part or added a new component simply by searching VCC. So what simply it does is it provides the power supply. Okay. So now I just connected this VCC to this DHT22 sensor. Okay. Now apart from that, there is if there is a plus VCC means a power supply, which is a plus terminal, and there should be a negative terminal as well. So this is the ground, which is the negative terminal. So again, to reduce the wiring and all, I could have obviously connected it with the ESP32 ground. Because, if you can see here, there are ground terminals present here. There is one ground here, there is one ground here, which is already used for various sensors. But for this, to make the wiring less confusing, I have connected it with a separate ground symbol. Okay. Now this is the connection, and now obviously whatever the temperature, this temperature and humidity sensor will sense, it has to go to this controller board so that our system will know what is the temperature, what is the room temperature, right? So how that is done is, this is the pin, SDA pin. It will transfer the analog values of the temperature and humidity to this uh, the board, which is by this pin, which is D26. Okay, so D26 simply means digital 26 pin of the ESP32 board. Okay, now this is the simple connection for this DHT 2022, sorry, DHT 22 sensor. Okay, now apart from that, there is another component, which is our buzzer. So buzzer has only two connections, which is plus and minus. Now, since we will be controlling the buzzer using the ESP32 board, so we simply need to connect it uh, the positive terminal with the ESP32 board's digital pin, which can simply, whenever we set this digital pin 19 as high, it will provide the power supply to this pin, and it will power on this buzzer. Okay, so which is why we have connected this buzzer pin, the positive pin, with the D19 digital pin, and the negative pin is, or negative terminal is, connected to this ground. Okay, so this is a simple connection for this buzzer. And now comes the ultrasonic sensor. The ultrasonic sensor that we are using here is HCSR04. Okay. And here, as you can see, there are four pins or four terminals: VCC, trigger, echo, and ground. Okay. Now, VCC is simply connected as I did previously here. I added a new VCC symbol here and connected it. Same for the ground as well. Okay. Now the trigger and echo pin. So the trigger pin is connected to pin D18, and for echo pin, it is connected to pin D5. Okay, so this is the basic connection for ultrasonic sensor. Now, if you also one more thing, yeah. So if you don't know how ultrasonic sensor works, is the basic idea is that the ultrasonic sensor will send a signal and receive the signal back after coming in contact with an object. Okay, so let's say there is a human or an object coming in front of the ultrasonic sensor. Then what it will do is, it will the signal will the ultrasonic waves will go, and once it touches the object, it will come back. So the ultrasonic sensor will send and receive the signal. Now in this, when the signal is sent, and we measure the time, and when the signal is received back, whatever the time taken of sending and receiving the signal back, in that time we can measure the distance. Okay, because we know that the speed is equal to distance upon time, and ultrasonic waves have a speed of their own. So we are using that, we can measure from the formula, speed is equal to distance upon time. So distance will be speed into time. So using that formula, we can calculate the distance of the object. Okay. So in this manner, the ultrasonic sensor works, and using which we can calculate the distance of any object coming in front of the sensor. Okay. Now this is the PIR sensor, which is majorly used for human detection or human presence. Okay. So which is the same reason we have added this, because let's say if in our room we have a human detection or human presence, then we need to turn on the lights and fans, okay, automatically. So how that can be done is, obviously, uh, the sensor will send a signal, will keep sending on the signal, and whenever it sees the presence of human, then the signal will come back, and it will using this digital pin, it will send back a high signal that there is a human present. Okay, so now the basic connection is VCC is connected to this VCC symbol. and the ground or negative terminal is connected to this ground of the ESP32 board, and this digital pin or the signal pin is connected to the pin D15 of the PIR sensor. Okay. Now, after the PIR sensor, we have this LDR sensor. Now, LDR sensor is LDR simply stands for light dependent resistor. Okay. Now, the basic idea of LDR is it detects the intensity or the presence of light inside a room or in the environment where this sensor is kept. Okay. So let's say in my bedroom, if I'm keeping this LDR sensor, then it will provide me the intensity of light uh, around this sensor. Okay, so this is the main LDR, and this is the LDR module, LDR sensor module. Okay, now the connections are not very difficult. Here we have VCC connected to this VCC symbol here, and the ground is connected to again the same ground of the ESP32 board to which this PIR sensor is connected. And there are two more pins, which is analog A0 and digital D0. Okay, so the basic idea is whatever the values this LDR is detecting, so it can, if we receive it in analog, it will range from 0 to 1023, and if we receive it in digital, it will be in 0 or 1. Okay, so for this project there was no need for us to uh, receive it in analog, so we just simply received it in digital. We can also we could have also done it in analog as well, but for right now we just need it in digital, so we just connected this digital pin with the D2 pin of the ESP32 board. Okay. Now, after that, we have used a servo motor. Now, the basic idea of using a servo motor is, now let's say we have used a ultrasonic sensor here, right? So now ultrasonic sensor, it will be kept at the door. So whenever a human presence is detected at the door, so what we need to do is we need to open the door, right? So the servo motor will be, the idea of using the servo motor here is to simply open and close the door. Okay. So obviously in real life scenario, not this servo motor can be used, but a similar kind of mechanism can be used to open and close the door. Okay. So in this prototype, we can use this servo motor. Okay. So the connections are simple here as well. We have connected this VCC, the V plus terminal to this VCC, obviously to provide the power supply. I will make this connection wire as red. Okay. Now this is the ground or negative terminal. So simply it has been connected to the ground, and the PWM pin or the signal pin is connected to the D4 of the ESP32 board. Okay. So mostly for whenever we are working with sensors or any type of actuator as well, there are basically major three types of uh, wires or terminals or pins. For one will be VCC, second will be ground, and the third will be the signal pin. It depends on the sensor that we are using majorly. See, as you can see, for this actuator, for this sensor, there are three pins which are majorly needed. But for, let's say, for ultrasonic sensor, there are four pins, right? So it depends upon the sensor or the type of sensor we are using. But majorly there are three main pins: VCC, ground, and signal. Now here we have two signal pins. One will be to send the data, and one will be to receive the data or send the ultrasonic sensor waves, and one will be to receive the ultrasonic sensor waves, right? So in that manner, we have four different pins. Okay. So this is the connection for servo motor. Now after that, we have a simple LED connection here as well. If you can see here, this LED is, let me just try to zoom in a little bit more. Yeah. So this LED is connected. Okay, sorry. So yeah, this LED is connected to the D13 pin of the ESP32 board. Okay, and the anode, or sorry, the anode is connected to the D13 pin of this ESP32 board, and the cathode is connected to the ground. Okay. Simply, now the idea of, as I said, the idea of using this ESP32 board, sorry, the LED is whenever the room temperature is a little bit higher, like let's say a room temperature is above 30 degrees, then we can set this LED as high and indicate on our mobile or Blynk app that the room is a little warm, so if needed you can turn on the AC or the fan as well, so that concept can also be included in this. Okay, so this is the reason why we have added using the why we are using this LED. Okay, and apart from that we have here two relays. Okay, so now there are two relay modules, and each of these relay modules are connected to two LEDs. Now why we are using LEDs here is actually we needed to connect we have to connect them, one with a bulb and one with a fan, to control the bulb and fan of our bedroom or our room. But since in this platform which I'm using, there is no option of adding a bulb or fan or any similar type of component or module, so I had to just for the sake of making our project working or prototype working, I have added LEDs here. Okay, so this yellow LED will indicate bulb, and this green LED will indicate the fan. Okay, so now the basic idea is both of them are connected with this relay module. Okay, and uh, this again here VCC and ground. VCC is connected to this, and ground is connected to the ground pin of ESP32 board. Same goes for this as well. ESP ground is connected to this ground terminal, and VCC is connected to this VCC. Okay, so this VCC was also connected to this DHT 2022 board, DHT22 sensor. Okay, now, apart from that, there are two signal pins one signal pin for each of this relay module. So basically, what this digital pins will do is in or what these terminals will do is it will receive signals from this ESP32 board. So let's say if I set D12 as high, then it will simply just receive this signal as high, and the relay will switch. Okay, and whenever the relay will switch, it will send a high signal to this LED or the fan so that it turns on. Okay, so that is the basic idea. And similar manner, this D14 pin is connected to this in pin of the relay 2 module, and it will be further sending the signal to this LED, okay, or the bulb. And the connections for these LEDs, these two LEDs, the cathode is connected for both of them to the ground here. This is the ground, and the yeah, so the signal pin or the power supply pin is connected to this uh, NO pin of this relay. Okay, and also there is a VCC provided to this COM pin of this relays. Okay, so overall, this is the circuit diagram or the connection for our project. Now let me see if I have missed anything. I have covered each and everything. Okay, just move it back here. Okay, so the connections are proper. Yeah. So yeah, this is the complete connection of the project. And in case you have any doubts or anything, then you can just let me know. So I hope I have explained each and every concept of why we are using that component, and why each and every terminal is what each and every terminal is receiving or sending. Okay. So yeah. So now once since we are done with this circuit diagram, let's just move on to the code. So, okay. So now here we have the project code here. So let's just remove the circuit diagram for now. So the code is a little bigger, obviously since this is a big project. So let me just scroll down first so that you can have an overview of the code or the length of the code. But now let's just try and understand the basic part of this code so that you can understand the basic idea of the code or the logic behind the working of our project. And then we can, if anything is missing out, then we can understand while we are practically seeing the working of this project. Okay. So now here the very first three lines here are defining something. So now the basic idea is we are connecting our project with our Blynk mobile app or Blynk console, if you can see here. So the Blynk cloud is the basic cloud that we are using to uh, connect our project to IoT cloud, and using that concept, we can check the status of our, uh, let's say for fan or bulb, or let's say for fire detection and all. So for that, we will be using the Blynk app, and for that, to make the connection possible, we need these basic three things to be mentioned in our code. This is provided by our Blynk app as well. So like, let's say when I uh, in this, if you can see, there are my devices. There is one device which is which is this name given, and for each of the device that you add here, you can see there will be the configurations provided. Let me see if there is. Yeah, so here you can see this these three line of codes will be provided here, and uh, it is mentioned here like template ID, device name, and authentication should be declared at the very top of your firmware code. Okay, so which is why we have copied this and pasted it at the very top of our code. Now, it is important to make sure that we just directly copy it and paste it from here, so that there is no change in anything, because this is the authentication token. uh, and this is the name of the our Blynk template, and this is the template ID. Okay, so these three are very important for our project. Okay, now after that, we have defined various libraries that we will be using. Now in this platform, walkway platform, we apart from directly mentioning the name, we also have to install few libraries, like let's say here for ESP32 board servo and DHT sensor and the uh, Blynk connection app. We have to install this, mention these three libraries, and also not only that, but we are in this library manager. We have to install these three libraries. Simply, how we can do that is just click on this add new library and search for the library that we have that we need. Like let's say for Blynk, if I search for Blynk, there will be a lot of options here, and for that we have used this library. Okay, in similar manner for each and every libraries, we can just simply search it and choose it from here. And if in case there is the library that we are using is not available, then we can upload it by uh, either creating it by ourselves, or but if you do not know that, then if we can just simply get it from internet and upload it here. Okay, so here we have mentioned all the required libraries for servo motor, for temperature, DHT sensor, and for this will be, this three will be for the Wi-Fi connections and the ESP board and the Blynk app. Okay, so these are the libraries that we have added. Now, apart from that, I have created a few objects, obviously, for since we are using here three main libraries for our project, we need to create an object so that we can call them and define further variables or anything if needed. Okay, so here these are the three main objects that we have defined. First is for DHT ESP, which is the name of this library. I have defined DHT sensor. Okay, then for servo, I have just named the object as servo only, and for Blynk timer, the object is timer. Okay, now here, I have mentioned the pin numbers for each and every variables that will I will be defining, or for each and every sensors that I have connected. Okay, so here let me just try and explain to you each and everything, or each and every one of them. Okay, so the DHT pin is the pin 26. Let me just bring my circuit as well here. And let's just try to zoom in a little bit. Hmm. Okay, so here if you can see DHT pin 26 is mentioned, and again here this will go to pin D26 here. So right, in this manner I have just mentioned here 26, so that the our code will understand that our DHT pin is connected to this uh, 26 pin of the ESP32 board. This sensor is connected to the 26 pin. Okay. In similar manner, trigger pin is connected to 18, and echo is connected to 5. So the variables are trick pin and echo pin. So all of these are the name of the variables that we have defined, and these are the pin numbers. So this is the format that we have used for all of the this defining the components of the pin numbers for each of them. So trigger and echo 18 and 5. You can see here trigger is 18 and 5 is for echo. Okay. For PIR pin 15 is used. here the same thing you can see. So in this manner we have used for each and everything. Now I will just explain the important things. uh, Again, fan relay. Why fan relay? Because we have to simply give a name. There are two relays, so one is used for fan. So as I said, this will be this LED will be considering as a fan, and for this we will be considering as bulb. So in this manner, this name for this relay is fan relay, and this is for bulb relay. Okay. So in this manner, fan relay pin will be 12 and bulb relay will be 14. LED pin, simple LED we have. So LED pin will be 13. Buzzer pin, it directly goes to this D19 goes to this buzzer. So which is why 19 here. LDR pin, simple again, directly goes to this pin here. D2 will go to this LDR sensor, and servo motor or the servo pin will go to pin 4, which is this. From here, it will go to pin 4. Okay. So in this manner, we have this pin connections or uh, yeah, the pin connections mentioned in this code. So which pin is connected to which terminal of this ESP32. So the basic idea is, now we have told our ESP32 board that in this pin we have connected, uh, sorry, in this pin we have connected something, and for that we will be defining, or whatever we will be doing, we will be doing with the use of this variable. Okay. So for DHT or for the temperature sensor, we will be getting the values from that sensor, and let's say for servo motor we will be sending the value to that sensor, right? So how we will be doing that is by the help of this variables. Okay. So where we will be using in this future part of the code. Okay. So let's just see what more variables we needed to define. So here I have defined duration, distance, door status, human presence, fire status, bulb status, and fan status. Okay. So these are very basic variables. Let me just explain to you them a little later, while where you see where they are exactly used. Obviously, from the name itself, you can understand. Like here, this two will be obviously to mention the duration and the distance. And as I explained when while explaining the ultrasonic sensor funda, we will be mentioning the we will be first measuring the time duration, and based upon that we will be measuring the distance, because speed will be sorry, distance will be speed into time. So based upon that, time is needed. Speed we already know, because the this ultrasonic sensor will pass ultrasonic waves, so you can just simply google the speed of ultrasonic waves, and from that you will be getting the speed, and that you can multiply with the time duration, and that you will get the uh, value for your distance. Okay. Now this all of these variables are defined. So what we have to do is we have to understand the void set of loop. Okay. So this is first loop, where here, as I mentioned here in the comment, here we define the or here we begin the serial monitor, and here we define the input output pins. So if you do not know what serial monitor is simply a debugging platform, or a serial platform where we can not only check the output of the code sometimes, but also we can debug our code if needed, or uh, just keep on trying and checking if there is any uh, like, it depends mostly majorly on the output. Like, let's say I want to check the how my output of my code is coming, then we can print the output on the serial monitor and check whether the values are fine or not. So in that manner we use the serial monitor. So here for this platform, walkway platform, this is the serial monitor here, that this small screen that you can see, or small area of where the values are being displayed. This is the serial monitor. Okay. So this is the output that we got for our project while I was running before creating this video. So we'll also see the output, but now let me just delete this. Okay. So this is the serial monitor. Now to turn or to begin the serial monitor, first, the very first line we write is serial.begin, and we provided a baud rate. Okay. So this is the basic code for this serial monitor. Now, if you do not know how serial monitor works, or if you are very new to this concept, then I can share a few videos, or I can recommend you a few videos which you can refer to understand this, because to explain this, it will take some time, which is not needed exactly for this particular project. Okay, so I will not take much time to explain all of this basic concepts. Now here, uh, this pin mode is in general used for defining the input output pins. So here, if you can see, what I have done is pin mode, PIR pin, and defined it as input. Okay. So what is this PIR pin? If you go above here, if you can see here, PIR pin is already defined here, right? So we have defined that uh, PIR pin variable is connected to pin D15 of our ESP32 board, but also we are now telling the ESP32 board in this void setup loop that this pin 15 or the PIR pin is your input pin. So you can receive the signal from that. Consider it as input pin, and you should only receive the signals from this pin. Okay. So in this manner, for each and every variables that we have defined above, we are setting it as input or output. So the fan or relay, since we'll be sending the signals and turning the relay on to turn on the fan or bulb on, so those will be output pins. LED pin will be again output pin, buzzer pin will be output pin, trigger pin will be output, and echo pin will be input, and LDR pin will be again input. Okay. So again, so yeah, trigger pin and echo pin. So trigger pin, as I said, for ultrasonic sensors, the concept is to send the signal and receive the signal back, the ultrasonic waves. So the trigger pin will be used to detect the to it will be helping us whenever we set this trigger pin as high, and we denote that time, like let's say right now at 150 and so seconds, I'm setting the trigger pin as high. So at that particular time, I can measure that time and set it as high, so the trigger pin will send the ultrasonic waves. And the echo pin, it will receive the echo pin, or the on this here, the whenever the signal the ultrasonic waves are received back, the echo pin will give us the value, uh, which is why here it is input, and the echo pin will give us the value of uh, how much uh, how much time it took to receive the signal back, right? So in this manner, we can calculate the distance using the ultrasonic sensor funda. Okay. And here, all of this are defined, the input and output are defined here. And again, now this digital write, this is a basic command that we use to set a digital pin as high or low. Okay. Or if you want to send any value, then we can also do that, but right now here, we are majorly using it for turning off or setting the values of our fan and bulb relay as off or low. Okay. So which is why I mentioned here as fan relay pin and bulb relay pin as low for now. Okay. And here another command here is mentioned, which is servo dot attach and servo pin. Okay. So now servo pin we already know here, sorry, servo pin we already know here because we have defined it. Servo pin is connected to pin 4. So now what we are explaining basically to our code is, now here if you remember, this servo is an object that we have defined here. Just 1 second here. Yeah, so if you can see, this is the for this servo library, we have defined this servo object, which is with small s. Okay. And what we are doing is, for this servo, we are using this attach function, and giving a command to our ESP32 board that we have attached the servo for this particular pin, at this particular pin. Okay. So that is what is happening with this line of code. Okay. Now if you want to understand more about this servo, uh, what are the different commands or functions for the servo library, there is there is a servo library description present on this Arduino website. You can check this out. Like let's say for the servo command, it has a description like servo.attach pin is mentioned, and also there is another command servo.attach pin min and max. Okay, so you can check this out. There are various different commands, and you can just go to this servo library website and just check on here there are various commands, and each of everything will be explained here in detail. Okay, so that is the thing. Now, apart from that, similarly for servo library, if you do, and if you do not understand for the DHT sensor, you can just Google it as well. But now what we are doing here is for this DHT sensor, the object that we have created, we are using this setup function. We are just declaring that DHT pin, that is, which is the pin number 26 is connected to the DHT 2020 or 22 sensor, and we are also describing it as which sensor exactly we are using is DHT 2020, DHT 22, sorry. So DHT 22, why? Because there are different variants of this sensor as well. DHT 11 is available. So we need to uh, explain the ESP32 board and our code that in particular right now we are using DHT 22. Okay, and to connect it to which pin, which is DHT pin, which is I think 26, or what was it? Let me just see again. Yeah, pin 26. Okay, DHT pin is connected to pin 26. So here we have defined that. Now obviously we have, as I said previously, we will be connecting this board or this whole system with our Blynk app. So this is very similar to our serial.begin code or command. So here what we are doing is we have used this Blynk object, and we are setting it as begin and providing it our three details, which is Blynk authentication token. Here I have mentioned one thing here, which is the SSID or the uh, Wi-Fi or the name of our Wi-Fi that we are using. So for since for particularly for this platform, which is Walkme, we just have to mention it with walkwe and walkwe hyphen guest. Okay, and here we will be in general we will be mentioning the password, but for this there is no password. This is by default set for these two, the SSID name and password are set for walkwe platform if we are using walkwe with our Blynk app. So we need to mention only this walkwe under walkwe hyphen guest, and password there should be no, there is no password, so which is why we just provide it empty. Okay, so we just simply need to provide this command so that our Blynk app will understand that we are using our walkway platform, and this is the authentication token. So which which template we are using on our Blynk uh, to connect this system or the project. Okay, so the authentication token is available from here. Okay, so now apart from that, if you remember, I also installed one timer library, and sorry, not timer library, but Blynk already has it timer object. So and it has a timer inbuilt installed in it. So what we can simply do is using this timer function, I have sorry, using this timer object, I've called this set interval function. So what simply it will do is it will set a time of 1000L, which is 1000 milliseconds, which is 1 second, and run this command after every 1 milliseconds, which is this sensor data. Okay, now what is this sensor data? It is a function that we have defined. If you can see here, the sensor data is highlighted. Again, here sensor data is highlighted, and we have defined it as a function here, and we will be seeing what exactly this function is in detail uh, just after we discuss this void loop. Okay, so what will happen is after every interval of 1 millisecond, 1000 millisecond or 1 second, this sensor data will be called, and all the sensors data will be in general read from the sensors, or whatever the idea of our project is will be happening in this function. Okay, now, void loop is the main loop which will help us to uh, make the Blynk run. So the basic command is Blynk dot run, and for timer dot run. There are two commands, Blynk dot run and timer dot run. So majorly it works when it is needed whenever we are using a Blynk library or a Blynk project. So these are the two commands that we majorly run. Obviously, Blynk run will be uh, explaining the system or the Blynk app that to turn on all the features of our Blynk project or the Blynk prototype in this template, and the timer will set the timer obviously. Okay, so from that we can measure the timer for this for this 1000 millisecond thing, and also for the ultrasonic sensor thing whenever needed. Okay. So now let's go to this sensor data function, which is here. So what will happen is whenever the sensor data function is called here, it will just scroll down. Sorry, the code will reach here. And in this function, what will happen is, firstly, what we are doing is we are reading the temperature and humidity sensor data. Okay. So again, for that, we have a temp and humidity object, which will give us the value in this data. And the command is dst sensor dot get temp and humidity function. Okay. So this is the function which will simply give us the values for temperature and humidity. Now, inside the data of temperature and humidity will be stored in this. Now, to store it in both for temperature and humidity, we need to, since this will be two different values, so we need to store them separately. So, for temperature, I have defined a float variable t, and we have written the command here as data.temperature. So it will provide the value of temperature inside this variable, and using the same concept, we define the value of humidity in this h variable. Okay. Now, as I explained here, this serial monitor here we can use to display the values, or even check and debug our code whether everything is working fine or not. So here what we can do is, using this command serial.print, uh, serial.print, we can print the values here. Now how this is working is, so basically, uh, this is the line that will be printed, and using this command we will be setting the or printing the values. Okay. So here what I'm writing here is data dot temperature, uh, and since we are presenting a string in this serial monitor, we need to convert this data into a string as well. So that will be converted it into string and then presented in one line. Okay. Now obviously I could have done another way as well, like here. In this manner, I could have done one more thing, which is serial.print. Let's say m is equal to semicolon line name and serial.print.println. Could have just simply done this. So what would have happened is, here, the output in my code would be in the serial monitor here would have been something like temp space is equal to, and here the value of t, let's say uh, 20. So 20 will be mentioned here, right? Okay. Now let's say if I want to, after that, also mention the degree Celsius as unit, then I could have printed serial.println. Just remove ln here. Now the difference between serial.print and serial.println is, serial.print will print, like, let's say this thing, if you can see here, print and print, if I'm using print here for both of them, then it will print both of them in the same line. And again, this will, whatever I'm writing here will also be printed in the same line, but whatever will be printed after that will be printed in the next line. Okay. So which is why print ln. Okay. So now let's say if I want to add the symbol as well, then I can just mention here as for C for Celsius. And then let's say if I want to copy this symbol for degree as well, I can just do that. Okay, so it will show us degree Celsius, and the output here should be and is equal to 20 degree Celsius. Okay, so why there's no space between here, between 20 and degree Celsius? Because I have not added. So if I want, I can just add this space here, and here again there will be a space. If not, then I can just undo this and the space will be removed. Okay. So this is the concept. So instead of writing these three lines of code to print the temperature, what we have done is simply, I just keep this and comment it for now so that you can use it for your future reference as well. Yeah. So what I've done is simply I just written this line of code which will do the same thing and in one line. Okay. So there's no need to write three lines of code of to do the same thing. So the same thing is done for printing the humidity value as well. Okay. And after that, we move to adding a logic to our code, giving a logic that now since you have the value of temperature and humidity stored in you, now do something with it, right? We need to do something. So what we are doing is we are first checking if the value is greater than 60. If the value of temperature, now we can set it to any values, like let's say for 100 degrees Celsius as well, or 1000 degrees Celsius as well. But there is a limit for this DST sensor. I think it measures from some negative values, from let's say from negative 30 degrees Celsius to 80 degrees Celsius or something. I'm not exactly correct, but something around that. Okay. So which is why we have a maximum temperature value of 80 or something around that. So I kept it here as 60 degree as a threshold value, and if the value goes above 60 degree, then uh, we consider that there is a fire in our room. Okay, so obviously 60 degree is not very high to detect fires and all, or for fires and all. Maybe the fires are at very high temperature as well, but for now, for this prototype, we are using this values as 60. Okay. So what we do is once we, if temperature is 60 or greater than 60, sorry. So what will the code do is it will set it as true and move inside this code. And what will happen here is digital write LED pin low. Okay. So firstly, obviously the LED pin is already low, but to avoid any disturbances in the code, or to say, let's say if our LED starts blinking automatically, to avoid that, because we don't need this LED on right now, because what we need is we need this buzzer to buzz, because there is a fire alert, and we also need to send a notification to our mobile. So there's no importance of this LED, so we just keep it off, and then we set the code for write the code for buzzer, which is to turn on the buzzer. So the command for that is tone buzzer pin and 1000. Okay, so now again this is a specific command for buzzer. uh, I'm not sure whether on walkWe this command would have worked or not, but we can also try with digital write, and uh, we can write here as buzzer pin comma high, but I'm not sure whether it would have worked or not. So which is why this, for any buzzer that we use on Arduino or related platforms, we use this tone function. Okay. Again, if you need to understand how this tone function or what is the concept of this, you can just Google, or on this Arduino reference website also you can find this library, and you can understand how this is working. Okay. And what I do is fire status. Okay, so for this is the one variable which you need to understand now. So now we have, uh, we know that the temperature is above 60, so we have a fire in our environment. Okay, or in our system. So what, oh sorry, nearby our system. So what we need to do is we set an alarm. Okay, obviously. So also here we need to, uh, so what I'm doing here is, this will give a notification to our Blynk app that our fire has been, fire alarm is active, and so there is a fire. Okay. So here I have printed a message as yes into this variable fire status. Okay, now fire status, where we have declared this. Here if you see, I have just here I told you, like, there will be, this will be, we will be discussing this later in this code. So here if you can see, string fire status is there. Okay, and by default it is set as no. Okay, so it means by default there is no fire. Okay, and it is defined as string, so we can write string values in it. Okay, and here, so what we are basically doing is, in this line of code, we are basically writing that fire is detected since the temperature is above 60 degrees Celsius. Okay. So fire is yes. Okay. And also what we are doing at the same time is, we on the serial monitor also, we are printing fire detected and very high temperature. Okay. So obviously instead of you are using any display device, like let's say an LCD module or something, you can display the same message on this LCD display. Okay. And now apart from that, now we need to send a notification to our Blynk app. So what we do is we just write this line of code, which is blink dot log event. So now there is a concept of event. Okay, so here in this Blynk, we have declared this project or template. So here if you can see, I have this template for my project. So here in this we have various options like info, metadata, data streams. So here I will explain each and everything here, but for now only what we need to understand is this events wala funda. So here in this events, there are three things which shows our system is online, offline, and there is an option to add a event as well. So how you can add an event? You can simply just click on this edit, and there will be an option to add a new event. Okay. So right now I don't need to add an event because I have already added the event. So here I'll just click on this, and here you can see the event name is fire alert, and event code is also present. So event code is automatically generated when we provide an event name. Okay, so our event code is fire underscore alert, which is the same name that I have mentioned here, fire underscore alert. So what we are doing is we are giving a signal to a Blynk alert, Blynk uh, cloud that log event. Which event? Fire alert. Okay, so the name of this event or the event code is fire alert, so it needs to uh, start this event, or it needs to trigger this event. Now what will happen is here the event type I have defined as warning, and in this note here there is an option of add notification as well. And here there is also an option to show event notifications in mobile app. So I have turned this on, okay, and also send it to timeline. So I have kept these options on, and in this notifications bar, we have to choose like whether how notification should be received. So it will provide push notifications to device owner, which is my Blink mobile device, and also send an email to the device owner, which is my registered email ID registered on this Blink app, okay, or the Blink platform. Okay, so once this is done, we can just click on the save. Now this is already saved, so I will just click on cancel. So this is how the event is created. Now fire alert event has been created. So I have just wrote this line of code, which is blink.log event fire alert, and now here there is an option to write a particular message if you want. So I have just wrote a string which is very high temperature detected, and if you want, we can also send the temperature value, which is using this uh, plus and t. Now why t here? Because t is the variable where we are storing the temperature value, right? So here and here, if you can see, this is where we store the temperature value in t. Okay, so which is why this whole sorry, in this manner, we can send a notification to our Blink app that fire alert has been, sorry, there is a fire alert, and also an email will also be sent. Okay. Now, after that, now let's say this is the condition for temperature greater than 60 degrees Celsius or for fire detection. But now let's say for room, uh, let's say the room temperature is around 20 to 25 in general, but it goes above 30. So when the temperature is above 30, it will just simply provide us a message that the room temperature is a little high, and whatever actions that are needed to be done they can do. Like let's say if they want to turn on the fan, or they can turn on the fan, or they can even turn on the AC. We have not installed those systems here in this part of the code, but that can also be done. Let's say for turning on this fan here, this we can just simply just send a high signal to this relay that, and that will turn on the fan. But right now we have not embedded this in our code. Okay, and what else is happening here is we are setting this LED pin as high. So simply the use of this LED is to just detect that there is a room temperature is little high. Okay, so nothing apart from that is this LED used for. And there is no fire, so fire status is no, and there's need for any alarm, so buzzer is also no. So here if you can see, the for this buzzer there is no tone, and here for no buzzer there is a no tone command. Okay, and apart from that, let's say if the temperature is below 30, then what we need to do is it will go in this else loop, and even this LED will be low and nothing will happen. So fire status is also no, and buzzer is also off. Okay, so everything is off. So this is the funda for the temperature and humidity sensor. Now let's move on to this LDR sensor data. Now for this LDR sensor, uh, okay, sorry. Yeah, so for this LDR sensor, what we are doing is we have created a variable which is LDR, and in this whatever we are storing, this LDR pin is the pin where we have connected this uh, the LDR D0 with this D2, and D2 is defined with this variable LDR pin. Here you can see LDR pin is defined with D2, right? So here, uh, sorry, that was the code. Yeah. Okay. So yeah, this is the LDR code. Now what we are doing is we need to read the value from this LDR pin. So what we do is digital read. Why digital read? Because this is connected to the digital D0, not analog A0. So if it was analog A0, we could have done analog read. But for now, we can simply go with digital. So digital read LDR pin. It will read the value of whatever is being received to this D2, and it will store it in this LDR variable. Okay. Now then also using serial monitor, we can print we can print the value on this serial monitor using this thing serial.println command. Okay, the LDR value will be displayed. This will be displayed in manner like LDR dot, and let's say the value is, let's say, 20. So this will be printed on the screen in one line, because here serial.print is mentioned and here serial.println is mentioned. So which is why both of them will be in one line, and whatever will be printed next. So when I say whatever will be printed next, so now here I have used the serial command. Now next time using the serial command here. So the next thing that should be printed on the serial command is human presence detected, right? So this human presence detected will be presented in this next line here, like somewhat like, let's say this is the output of the serial monitor here. So it will be writing here as human presence detected. So this will be the idea of the output on the serial monitor. So now here, what we are doing is, if the LDR sensor value is high or low, based upon that, we need to do something, right? So basically, the LDR is used to for the detection of light in the room, right, or to check the intensity of light. So here, for this platform for Walkme, it is the light intensity is measured in terms of illumination, something, and so the basic idea is we check whether it is high or low. Okay, so here what we do is uh, so there's no need for this comment here, but I have written it for your understanding. Now let's say if when I will explain this to you when I run the code. So for that we need to understand why LUX value should be less than 100. Okay, so I'll just explain this to you when we check the practical working of this code. Okay, so just consider for now that if LDR is equal to high, then what we need to do is so when LDR is equal to high, simply means, or equal to 1, simply means that there is a presence of less sunlight or darkness in the room. So we need to turn on the lights. Okay. So simply what we do is we just write command digital write bulb relay pin to high. Okay. So bulb relay pin simply is connected to the bulb. So it will set this relay pin as high, and in further it will, what it will do is it will turn on the bulb. Okay, so that will be done. The bulb will be turned on, and after that the bulb status is also set as on. Okay, now why this bulb status is on? So what will happen is this on string, this is a string which is stored in the string variable bulb status declared here. So bulb status is in general off, but now it has been changed to on, and here is on, and later on in this code we will understand what is happening. But right now I can just in simple manner explain that we are sending this to our Blynk app that the bulb status is on or off. So it will keep sending the values. So right now it is on, so it will send the on value. So I'll explain this in the later end part of the code. Okay, so the bulb is on, and if the LDR value is not equal to 1, which is whenever it is 0, it will the bulb status is off, and the bulb value or the relay pin for the bulb is 0. Okay, so in this manner we turn on and off the bulb based upon the LDR value. Okay, now after that this is the now this is the part where we discuss the PIR sensor data. So here what we are doing is we read the value of PIR, and based upon that we can turn on the lights and fans of the room. Okay, so simply the PIR pin is connected to pin. What pin is we are connecting the PIR to? Pin D15. So pin D15's values, using this digital read function, we can read, because obviously we need to understand if there is human presence. If human presence, then it will send us a high value or one value. So if one, then what we can do is, it firstly we are storing it in this PIR value named variable. So if PIR value is high or one, then simply it means that there is human presence. So which is why this variable, string variable human presence, is set as high or yes. Okay, and also in the serial monitor, we are using serial.println and mentioning human presence detected. And also what we are doing is, since human presence is detected, it means that someone is present in our room. So we need to turn on the fan, and if it is night time, then we can turn on the light as well. So for that concept, the fan is turned on using this digital write command, which is fan relay pin high. So this fan relay pin will be high, and not the bulb right now, but whenever the fan is connected here, it will be on. Okay, and again here this string variable fan status is kept as on, and later, like similarly to the like the bulb status, the fan status will be sent to the Blynk app or the Blynk cloud. Okay, now this fan status is done. Also on the serial monitor, we are printing that the fan is on, and inside this, now the fan is on, but we need to check, for before turning on the lights, we need to check whether the whether it is darkness or sunlight is present, or whether it is morning or night, right? So using this again, the LDR wala funda, the LDR funda, which is LDR detects the light intensity in the room. So if the LDR is high, which is the same concept which we used here, it will turn on and off the lights. Okay, so again the same thing. And here this complete part is for the LDR only, so there's no need to explain it again, because it has been already covered here. Okay, the same thing has been covered here. Okay, now this was the part of the code where human presence was yes. Okay, sorry, not this much, but this was the part of the code where human presence was yes, right? So there was a human presence detected, but if there is no human presence, then it will go in this else loop, and here it will print human presence is no. Sorry, it will uh, store the value of no in this string variable human presence, and further it will be sent to the Blynk cloud using this command, which is this command. Okay, and here what else is happening is, on the serial monitor we are printing no human presence detected. On digital write, sorry, in this we are what we are doing is, using this digital write, we are setting this fan as low. If this was, let's say, previously on, but the human has went away from the room, we need to turn off the fan as well, right? So this will be set to low. Okay, and also we are printing on the serial monitor that fan is off, and also we are sending the value of off as fan status to our Blynk cloud. Okay, so this is the funda for our PIR sensor, and this is how we turn on and off the lights automatically. So now the last thing according to me is left, whatever is left is this ultrasonic sensor. So here in this part, we read the value from the ultrasonic sensor. So simply what we first do is, initially the basic idea is what I said is, like, we need to send the signal to send the ultrasonic signal, right? And whenever it is received back, we measure the time in that manner, right? So whenever it is sent and whenever it is received, we note down the time, and that time interval is measured. So before that, what we need to do is we need to send the signal. So that is done using this trigger pin, by setting this trigger pin as high. But before that, we make sure that trigger pin was low before that. So which is why this command digital write trigger pin is low. Okay, so it makes sure that our trigger pin is low, and after a delay of 2 microseconds, so this command will provide a delay of 2 microseconds, and after that it will send a signal, or send an ultrasonic wave using our ultrasonic sensor, and after a delay of 10 microseconds it will stop. Okay, so now it has sent a signal. So whenever it is received back, what will happen is, using this echo pin, we will see whenever this echo pin is high. So now it will what will happen is this ultrasonic sensor will send a signal whenever this command is run, so it will send high. Okay, so but if let's say there is no object in front of it, so the signal won't receive back. So the echo pin, which is the pin which will tell us whether there is an object or not, it will be always low. Okay, but let's say there is an object in front of it, then what will happen is it will this echo pin will be high, and it will tell us that there is an object in front of it. Okay, so in this manner, what we can understand is there is a person or an object standing in. So now, obviously, here we could have used the PIS sensor again, but why not use an ultrasonic sensor to understand? Okay, so obviously we can change this and convert it into a PIS sensor for human presence only. But for now, we just keep it as ultrasonic sensor. And simply what we do is we use the we get the value of echo pin is high, and whatever the value is, using this pulse in function, it will measure the duration, like whenever the signal was sent using this trigger high, and whenever this echo pin received the signal as high, it will the time difference will automatically be calculated, and the duration will be measured, okay, using this pulse in function. Okay, again, for that, if you need to understand from this Arduino website, you can understand that, because this is the uh, this is the basic Arduino IDE code only. The funda is exactly the same, so you can understand from that and website. Okay, now after that, we have measured the duration. Now previously I told you that we can measure the distance using the speed is equal to distance into time formula. So here we have distance is equal to time into speed. Okay, so now here the speed of ultrasonic waves is calculated, and it is divided by 2. Now why 2? Because we are sending the signal and receiving it back. So in this manner, what we are doing is there are two pathways, right? It is going and coming back. So while it is going, there is a time, and while it is coming back, there is a time calculated, right? So we need to divide it by 2, so that we need to understand that what will be the distance exactly, right? So because like now let's understand, I'm going from point A to point B, and from point B I'm coming back to point A. So when now I if I measure the time uh, from which I from when I moved from A to B and came back from B to A, it won't give me the exact distance, because for to measure the exact distance, I need to only calculate the time from when I went from A to B, right? So now since we don't have the distance, we need to divide it by 2, so to get the distance, correct distance from going to from A to B, not from going from A to B and coming back from B to A. Okay, so which is why we divide this by 2, and 0.034 is the speed of the ultrasonic waves. You can just find it from internet, and uh, then we multiply it with the duration, and then we get the distance. Okay, so now here we have the distance. So this distance, we can check whether that an object is present in this object or human is present in front of this ultrasonic sensor. Now the basic idea is, if the person's distance is less than 50 centimeters, then we should open the door. If the person's distance is again greater than 50 centimeter, it means the person is far away, so there's no need to open the door. Okay, so now if person's distance is less than 50 centimeter, what will happen is this if loop will set high, and inside this what will happen is serial print door opened will measure sorry, this command will run, and door opened message will be printed on this serial monitor. Okay, and also the door status variable will be set as open. And what we are doing is, now since we need to simply open the door, and as I already explained while explaining the circuit diagram, that for now, for this prototype purpose, we are using a concept of servo motor. So we are changing the servo motor degrees from 0 degree to 180 degrees. Okay, so here what we are using is, we use this servo object, as I explained above, like when we were using the servo dot attach to begin the servo motor. Here we are using this servo dot write to give a command that what values or what degrees you should rotate. Okay, so here we are mentioning is to rotate at 180 degrees. Okay, we can also keep it as 90 degrees because in generally whenever the doors are rotating, it rotates at 90 degrees. But for now, I have kept it at 180 degrees. Okay, and the door will open. Okay, so this is the basic idea using which we are opening the door. But if the distance is above or greater than 50 degrees, sorry, 50 centimeters, then what will happen? The code will go inside this else loop and it will print door is closed, automatic door is closed, and the door status will also be closed, and it will be sent to the Blynk cloud, and servo dot write will be 0. So there will be no rotation, it will be at its position. Okay, now let's say if the door is open and then the person is far away or moves away from the door, then again the door will be closed and from 180 degree it will come back to 0. Okay, so this is the whole funda. Now after that, now let's say what we are, the basic idea is what we are doing is, if you remember, uh, in the void setup, I have mentioned this timer dot set interval, which is measuring the or calculating the or getting the sensor values after a interval of 1 second or 1,000 microseconds, right? So now after 1 second, we will be getting the sensor data. So we need to know, like, there should be a difference or gap, right? So which is why I've added this line. So from serial monitor we can know there is a difference in the values as well. Okay, so there's no importance of this line, you can remove this as well, but for my sake I have added this. Okay, now this is done. So after that, simply whenever we need to send data to our Blynk app, we simply, what we do is we uh, send it using this virtual write command. Now why virtual write? Because we have, what we have right now added or done is, what we have added is, on our Blynk app we have created virtual pins or virtual data streams, which is because we need to only display the status of our pins on our Blynk application, right? So which is why we are using this virtual pins. Okay, now how we uh, so yeah, so now how we send it to different pins is by keeping this whatever the values are with this, and sending it to the terminals. Okay, so now V0 is the terminal where we are sending the T pin, value of our T, which is the temperature value. So here, so here the V0 will be sending the value of the temperature, V1 will be sending the value of humidity, V2 will be sending the value of human presence, V3 door status, V4 bulb status, V5 fan status, and V6 fire status. Okay, so here all these values will be shared. Now what I will do is to understand what exactly V0 to V6 is and why exactly we wrote this virtual write. Obviously we could have simply written bring.write, because write is the command which using which we give values to something, right? As you can see, we I don't know whether we have used here, but uh, we in general write, yeah, here we have used digital write to give commands or to write values to something, right? So in general we write that, but here we have written virtual.write. Why virtual.write? Is the basic idea is because we have added virtual pins to our this uh, project on our Blynk module or Blynk app. Okay, so here I will, on my screen also, what I will do is I will start screen recording on my mobile and show you the Blynk app. And here, this, if you can see on my mobile here, this is the Blynk platform, and here this is our project home automation using Node MCU, and this is the basic idea. Here we have mentioned or shown three things, which is fan is on, fan is off, bulb is off, and fire, for fire we have mentioned no, which is no fire. Okay, now if I just click on this, you can see the whole uh, uh, whole status of the project. So with, sorry, you can see all of the components that we have included in our project, which is the status of the door, whether the door is open or closed, human presence is detected or not, bulb, fan, and fire, whether they are on or off, or whether there is fire or fire alert or not. Okay, and also the temperature and humidity values have been displayed here. Okay, so this is all the things. Now how we are getting exactly all these values, or how these values will be displayed us to us here, let's just click on the settings option. here you can see for each of them there is v2, v3, v4, something is mentioned here, right? So let's just click on them. So if you can see here, there is a data stream added to this. In this data section here, there is a data stream added, and then the name of this data stream is door status, and which is in brackets written as v3. So let's just click on here. So here you can see all our data streams are mentioned here. You can also create a new, sorry, I have changed this. This was door status, right? Yeah. Okay. So here you can see there are various data streams mentioned here, and all of them are on the right hand side. You can see virtual is mentioned, right? So what we are doing is we just need to receive the value. So which is why we have kept them as virtual. And what we need to do is, let's say if you want to create a new data stream, just click on create new, and it provides this option as virtual pin number. Okay, so if you want to set a virtual pin number, it option provides an option to set a lot of virtual pins, but since we need only 5 to 6, so we just kept it. And now let's say if you want to add a new pin, we just select v7. You can select v8 as well, or v100 as well, and set whether the data type is integer, string, or double. So let's say when I wanted to receive the value of door status as open or close, I would have set it as string. But now let's say if I want to receive the value of temperature, I will set it as integer. Okay. You can also set the minimum and maximum value for temperature. Sorry, for let's say for humidity, if it is in percentage, I will set it as from 0 to 100. And uh, let's say the default value should be 0. I will keep it as 0, and I will provide a name. So let's say for humidity, if we are doing, then I will write it as humidity. Okay. So then areas will also be provided. And if you want to add units, so let's say for humidity, if you are just measuring it in percentage, you can scroll down and see if percentage option is there. And here, if I can see percentage is there, degree Celsius is there. I'll just click on percentage and click on done. Okay. So now our V7, we have added a V7 data stream as well to this door status. But for now, for this door status, we need to check the door status only. So I'll just click on door status. Now, obviously, this is not the correct way to add data streams. If you want to add data streams, just click on this project settings here, and here here this is where you can design the project, basic idea of this project. Here, if you can see here, if you come back here, this is the screen. Here, whatever you are seeing here, you can edit this using this settings here. This is the same thing that you were seeing at the beginning, and the name of the project here, and whatever the labels that you wanted to see, you can choose it from this tile type. Okay. So now also there is an option to give a tile design, add colors, select the font size, and mention the names or titles. And the data streams here, using this we can create. Okay. So these are the data streams that we have created so far. And now let's say humidity, we have 2 times. So if I want to remove it, I'll just click on it, and on this three dots, I'll click it and click on delete. So I'll just delete this humidity, because now we have already humidity present here. Okay. So in this manner, we can create data streams from here, and from this code, you can get the authentication token and all. But authentication token, you once you create your ID, you will already receive on your email. If not, then you can also, if you cannot see it here, then you can also visit your Blynk cloud on your laptop, or from on your console, and sorry, on your website, and Chrome website, and just check your Blynk authentication token. Okay. So this is the basic funda for this project setting. And now I hope you understood the concept why we were using this V0, V1, V2, V3, V4, V5, and V6. We mentioned this here, and what exactly they are sending, right? So now this is the part where we come to a conclusion of that. Uh, Sorry, this is the part where our code is ending, uh, where our code is finishing, and this is how this code is. Okay. So this is exactly how our code is working. Now let's see how exactly our project is working. Okay. So let me just make it in full screen and bring this to a little sideways, so that you can also see my mobile screen as well at the same time. Okay. So here. So let's just try this project. So what we'll do is I'll click on start simulation. So here, since this is a free account, it will take some time to compile the project. It generally takes 15 to 20 seconds. Sometimes it takes around a minute as well, because walk fee is also has a paid accounts and all. But right now, since we are using a free one, it will take a little time. So if you can see right now, uh, this simulation has started now. Also, you can't see any values here on the serial monitor. It will again takes a little time to load, but it will start printing values. Here you can see the values have started printing here. Okay, so I haven't done any changes to the system or anything, but still you can see the values are being printed because our serial monitor commands have been added in our code. Here you can see temperature is 35, humidity is 40 degrees Celsius, room temperature is little high, which means that uh, in our code, if you remember, room temperature little high means the temperature room temperature is above 30 degrees Celsius. So if you want to check, just click on this DHT sensor, and if you can see here, it is above 30 degrees Celsius, which is 35. Now, if you want to uh, check whether uh, the temperature is low or not, then you can just reduce the temperature here. So let's just say, let's just make it below 30. Okay, so then it should change here. Let's see whenever this refreshes. So now here you can see room temperature little high has been removed here, and you can see temperature value is 24 degrees Celsius. Okay, and yeah, so the temperature thing has been done. Now again, if I just increase it above 30, again this LED should also be on, if you remember, because for in the code we have mentioned that whenever this is above 30 degrees Celsius, this LED should be on. It takes a little time to load, but here if you can see now, room temperature little high mentioned, and the LED is also on. Okay. Now if I set it to above 60 degrees Celsius, then our if I set it to above 60 degrees Celsius, then our fire alarm will be set, which is the buzzer will start buzzing, and also our notification will be sent to our mobile app. But let's do that at the end of this. But let's see all the other concepts of our code. Okay, so now this LED is off because the temperature is around 8 degrees Celsius. Okay, now let's just understand this ultrasonic sensor funda, which is it will open and close the door in presence of a human. Okay, so now here also you can see the same thing on the mobile screen as well. Okay, so now here the distance is around 84 centimeters. Now let's just reduce to 50, less than 50. So if you can see the servo motor rotated to around 180 degrees Celsius. If you uh, want to see it again, let's just it means simply the door has been opened. Now let's say if again the distance is increased to above 100 or above 50, the servo motor is rotated again to 0, and or the door is closed. Let's just go again. There will be a rotation now. See the servo motor rotated, and let's just go again and close the door. Okay, so there is a door close message mentioned here as well, and this degree is 0 now. Okay, so this is what is being mentioned now. Also, if you didn't notice, on the mobile app also the same thing has been mentioned. On the top left, you can see the door status. It is closed right now, but now as I decrease it below 50, it should come as open. See, now it has changed from close to open, and also on the same thing, on the same serial monitor, the same thing has been mentioned on the serial monitor as well. Okay, so let's just keep the door open as only and move on to our PIS sensor. Okay, so for PIS sensor, what we are simply measuring is human presence. So we just click on this, and here, since this is online, we need to use the simulation fundas only. So here I will just click on this simulate motion. So it will detect motion here. Okay, so now it will detect motion here. So the human presence should be yes. So let's just see now here, on the mobile screen, you can see human presence yes is mentioned. And here also human presence detected is mentioned here. And if you can see, this green LED or fan has been turned on, right? Now let's say with this, if you want to check the check or if you want to turn on the lights as well, we reduce the value to below 100. Okay, and let's just close this. And if you can see, this LED is also on, which means our bulb is also on. Okay, so this is how our human presence will work. Like whenever human presence is there, the fan will be on. And if also the room temperature is below, sorry, the light or intensity is low, or there is darkness in the room, the light will or bulb will also glow. And bulb will also glow automatically with the help of this LDR. Okay, and the same thing you can see on our uh, mobile mobile screen as well. The bulb is on, fan is on, and our human presence is yes. Okay, so also the same things have been mentioned here. Light is on, fan is on, human presence is detected. Okay, now the since this PIS sensor uh, simulate, now again I have to click on it, so it will provide me the motion. So then only motion detected will be motion will be detected, and human presence will be detected. Now in real life, we need to make this logic a little bit advanced, but right now for this prototype this logic works. Okay, so this is how this PIR sensor works. And also with this same thing, you also understood the basically the funda of this LDR as well. But let's just understand this again. So whenever this LDR is we change the value of LDR. So now if you remember in the code, I have mentioned LDR is equal to 1, right? Which means LDR should be high. Now, when it will be high, when this value is below 100. So if you can see right now, it is 8, which is obviously below 100. So which means that this yellow LED is glowing. Yeah, it means this bulb is glowing. Now let's just try this again. Let me just move this a little bit around and try to zoom in so that you can see both the things at the same time, which is the bulb and the LED or LDR. Yeah, right now you can see if I move it above 100, the bulb should go off. And also on the mobile screen, the bulb should be off, right? So if you can see, the bulb is off, and also here the bulb is off. Now let's just go again below 100. Now the bulb should turn on again, and on the mobile screen also you can see bulb is on, right? So in this manner we can see the status of the bulb. And while all of this is happening, you can see the temperature and humidity is also changing based upon the temperature of the room, and whatever the values that we received from the DHT 2022 sensor. DHT22 sensor, sorry. Okay, so in this manner we turn on automatically the lights and fans using the PIR and the LDR sensor. Okay. Now, this concept is done. We have understood the funda of ultrasonic PIR and LDR. We also understood this relay, because based upon this, only the relays will turn on. And here, this LED also we have checked, because whenever the temperature goes above 30, this LED will be on. See, okay. Now the only thing which is left is this buzzer and the mobile, the notification for fire alert, right? So now let's just set the temperature to about 60 degrees Celsius. Okay, and let's see if we hear a buzzer, hear an alarm from our buzzer or receive a mobile notification. I'm not exactly sure whether you will hear my system audio, but let's try. Okay, so I hope you could hear that. Also, here there was some symbols which was showing that buzzer is buzzing, and also on the mobile screen, if you can see, there is a blink notification which says for this home automation using Node MCU project, uh, there is a fire alert and the temperature is 70 degrees Celsius, very high temperature detected. Okay, so this is the notification. And not only that, on this mobile you can see I have open a notification bar, my notification bar, which again provides the same notification, which is fire alert. And if you want to check here, we can check on our Gmail here as well. The same thing will be mentioned. Okay, so here you can see this notification which says email notification which says fire alert, very high temperature detected. For this was 3 hours ago, but for now, let's say, yeah, this was 1 minute ago. Fire alert, very high temperature detected, 70 degrees Celsius. Okay, so this is how we can get the notification in our mobile app and also in our uh, email. So this is how our project is working. So this is the complete working of our project. And yeah, so in case you still have any doubts and all, then you can let me know and we can try to clear those doubts. Okay, cool. Then I'll stop the simulation and also pause, stop this video. Thank you.